Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper question on gravitational field from May June 2022, paper 4, variant 1. In today's class, we will discuss this question in detail so you can have clear understanding of this topic. Let's study together. Let's improve together. In today's class, we are talking about paper 970241. And this paper is from May June 2022 and total time for this exam is 2 hours. We need to answer all questions on this paper and the total mark for this paper is 100. On second page of your exam paper, you can find values of some important constants. So maybe you will need some of them for some calculations in your exam. So here is list of all important constants. Maybe you will need some of them in your exam. If you go to next page, on the next page, you can see a list of formulae. On one slide, you can see all the formulae for AS physics. So these formulae are from AS physics. They are from AS. And these all formulae, they are for A2 physics. So these are for A2 physics. But there is one subtle change in this formula list. In 2022, they have added these three formulae here. Because in new syllabus, we have new topic about astronomy and cosmology. So these formulae are for astronomy and cosmology. And this formula is for ultrasound. So this one is for ultrasound. So these are three new formulae in this formula list. And these formulae are from astronomy. For question number 1, part A, we need to state Newton's law of gravitation. And Newton's law of gravitation is a very common question from gravitational field. If you see any question about gravitational field on your exam paper, there are 80% chance they will ask you to state Newton's law of gravitation. And this question has 2 marks or 3 marks. So you need to understand how to state Newton's law of gravitation in a proper way. Let's try to understand how we can state Newton's law of gravitation. Imagine that we have 2 spherical objects. Let's say the mass of this object is m1 and the mass of this object is m2. We are taking spherical object because in this case we can assume the total mass of the object is concentrated at its center. So that's the reason we are taking these 2 spherical objects. And Newton's law of gravitation is only valid for point masses. So mass you can treat as a point mass if 2 masses are very far away from each other. Means the distance between the centers of the masses is much greater than size of the object. We can also treat as a point mass. So these things I have discussed in the other videos. You can check for more detail. But today's class we will just focus on how to state Newton's law of gravitation. Now imagine that the distance between the centers means the distance from center to center is equal to d. Then the force of gravitation between these 2 masses will be directly proportional to the product of these masses, and force of gravity will be inversely proportional to the square of separation between their centers. So this is how you can state Newton's law of gravitation. Let's say this is 1 and this is second. So we can write down this one in equation form. So we can say F is proportional to m1 m2 divided by d squared. We can write down in equation form now. We have to use constant. So we have capital G. This is universal gravitational constant. So we can say G m1 m2 over d squared. So this is equation you can use to calculate gravitational force on any object. For example, in this case, the gravitational force on this object, this is F1, let's say, and the gravitational force on the second object, let's say this is F2. So F1 in this case will be equal to F2 in magnitude, but direction will be opposite. So we can also use negative sign here. These 2 forces are equal but opposite in direction. Now let's try to write down our answer for this question. And also you need to understand gravitational force is the central force. So it acts from center to center. So maybe you imagine why the force is not in this direction. Because gravitational force is central force. So acts from center to center. Means it is acting along this line. This is how you can define Newton's law of gravitation. The first mark you will get if you have written gravitational force between 2 point masses. You have to be very clear. This law is only valid for point masses. So you have to mention point masses directly proportional to the product of their masses. You will get 1 mark, and that is the 1 mark. And the second mark you will get if you have written inversely proportional to the square of their separation, or you can say inversely proportional to the square of distance between their centers. You will get the second B mark. This is how marks will be awarded for this question. For the second part, we need to use Newton's law of gravitation, and we need to show that gravitational field G at a distance r away from a point mass capital M is given by this equation. So first of all, let's try to imagine what is given to us. Imagine that we have a point mass capital M here, and this mass has a gravitational field around itself. This question is simply asking us to find out the value of gravitational field at a distance small r away from this mass. At distance r means at this point we need to find out value of G, means we need to derive this equation, and we need to use Newton's law of gravitation. So first of all, we need to understand what is G. This is the gravitational force per unit mass. G is gravitational force per unit mass. So here we can write down per unit mass. So per unit mass. Unit mass is taken as 1 kg. So we can say unit mass is small m. Now you need to imagine at this point we place a unit mass. And we need to use now Newton's law of gravitation, and we need to find out magnitude of the force on this unit mass. That is what question is asking us. So simply in this case we can say G small g, this is equal to gravitational force. So the gravitational force between these two masses will be equal to capital G, capital M, small m, divided by the distance between the centers. These are point masses, so it simply means that you need to take the distance from this mass to this mass. And we need to divide this one by unit mass. So this is our unit mass. So in this case, simply you can cancel this m with this m. So we left with capital G, capital M over R squared. So this is what question was asking us to derive. And you need to understand this capital M, this is point mass. So this is point mass. This is not unit mass. This is point mass capital M. Or you can say this is source of gravitational field. Simply we can say this is source of source mass. We can write down simply source mass. This question has 2 marks. The first mark you will get if you have written gravitational force per unit mass. And the second mark you will get if you have derived this equation. So there are 2 marks for this question. For part B, it is given to us the Earth has a mass of 5.98 times 10 to 24 kgs and a radius of 6.37 times 10 to 6 meters. The Moon has a mass of 7.35 times 10 to 22 kgs and radius of 1.74 times 10 to 6 meters. The Earth and the Moon can both be considered as point masses at their centers. They have made this assumption, so we can use Newton's law of gravitation. We can treat them as point masses. Their centers are at a distance of 3.84 times 10 to 6 meters apart. Show that gravitational field at the surface of the Moon due to the mass of the Moon is this. It simply means that we need to find out value of G at the surface of Moon. First of all, you can imagine a beautiful moon. So this is a beautiful moon. For this moon, the radius of the moon is given. So we have the radius of the moon and we have the mass of the moon. Mass of the moon is given to us, that is equal to 7.35 times 10 to 22 kgs. And radius of the moon, imagine that this is capital R, means the distance from the center. This radius is given to us, and this is equal to 1.74 times 10 to 6 meters. We need to find out value of G. In order to find value of G, we need to understand G is equal to capital G, capital M over R squared. R is the distance from the center of the object. So this is the distance from center. So this is R is distance from center. Distance from center. And m is the mass of the source mass. In this case, g is a constant, and value of g you can find in the data, and g is equal to 6.67 times 10 to minus 11 Newton meter square per kilogram square. And the mass of the moon is given, that is 7.35 times 10 to 22, and the distance from the center of the moon is equal to the radius of the moon, and that distance is 1.74 times 10 to 6 square. If we solve this one, our final answer will be 1.62 newtons per kg. Newtons per kg. So this is value of g. Means this is value of g at the surface of moon, and this one is equal to 1.62 newtons per kg. It simply means that if you place a unit mass at the surface of the moon, 1 kg mass will experience force 1.62. If it is 2 kg, force will be double, and so on. So this is how we can answer this question, and this is what we need to show. G is equal to this one. And this question has only 1 mark. If you have shown g is equal to this, you will get 1 mark, and that is answer mark. Very straightforward question. Simply you need to plug in values. If you have basic understanding of g, then you can answer this one very quickly. For the second part, we need to explain why there is a point x on the line between the centers of Earth and the moon, where the resultant gravitational field due to Earth and the moon is 0. That point actually we call is a neutral point. Point x is called neutral point. Why we call neutral point? Because if we place any mass at point x, the force on that mass due to the moon will be to the right. We can say force by moon, and mass at neutral point will also experience force due to Earth. And these two forces, they will be equal in magnitude and opposite in direction. So the resultant force on the mass will be equal to 0. So the mass will just stay at rest if we just place at that point. So the net force will be 0. Another way to explain this one is the gravitational field. Gravitational field due to moon in this case is to the right, and gravitational field due to Earth at this point is to the left. And these two fields, they are equal in magnitude but opposite in direction. So that's the reason we call this point is a neutral point. And the net field at this point will be equal to 0. Means there is no net gravitational field at neutral point. And this point is very important. Very important, because if you want to send object from the surface of Earth to the moon, you only need to provide energy, enough energy, so that object can reach this neutral point. After that, we no need to supply energy, because then moon will take over, and due to attractive force of the moon, object will be attracted towards moon. And this is very important when we send any mission to any other planet, or we send any mission to moon. So the understanding of neutral point is very important. Now let me explain to you how you can write down your answer. This is how you can write down your answer. Simply you can say fields due to moon and Earth have equal magnitudes and they are in opposite directions. You also need to understand G is a vector, it's not a scalar. So very important point. You need to understand gravitational field, this is vector quantity. G is a vector quantity, not a scalar quantity. So this is how you can answer. This question has 2 marks. If you have written fields have same magnitudes, you will get 1 mark. If you have written they have opposite directions, you will get 2nd mark. For the last part, we need to calculate the distance small x of point capital X from the center of the moon. It simply means that we need to calculate this value of distance. Means we need to find out value of x. But for this question, the distance between centers of moon and Earth is given to us. So simply we can write down this distance. Value of this distance is given, that is equal to 3.84. So we can say this distance is equal to 3.84 times 10 to 8 meters. So this is the total distance. So we can say the distance between neutral point and from the center of our planet, that distance will be equal to 3.84 times 10 to 8 minus x. Now we need to find out value of x. But we have already discussed at this point, value of g due to our planet and value of g due to the moon is the same. We will use this fact and we will calculate value of x. So simply we can say g due to our planet at neutral point, this is equal to g due to moon. At neutral point, these two quantities are the same. So g due to Earth, we have to write down capital G. We need to write down mass of Earth and the distance between the neutral point from the center of the planet. And that distance is equal to 3.84 times 10 to 8 minus x square of this quantity. This one has to be equal to capital G times capital M, and this is the mass of the moon. Mass of the moon divided by distance between neutral point and center of the moon, and that distance we have said that is equal to x squared. So in this case, now we can cancel this capital G with this capital G, and we can plug in values of mass of Earth and mass of planet. In this case, we have mass of Earth that is given to us, that is equal to 5.98 times 10 to 24, and this is divided by 3.84 times 10 to 8 minus x square of this quantity, and this is equal to mass of moon. Mass of moon is given, that is equal to 7.35 times 10 to 22 divided by x square. Now we can cross multiply, means we can multiply like this, we can cross multiply, and then we can solve this one for x. If we solve this one for x, our final answer for x will be equal to 3.8 times 10 to 7 meters. So this is the distance from the center of the moon to the neutral point. So this is how you can calculate. So this is value of x. This is what we need to calculate. This question has 3 marks. The first mark is C mark. You will get 1 mark if you have written the distance between the center of Earth and the neutral point. If you have written that distance is equal to this, you will get 1 C mark. In the second C mark you will get if you have equated G due to Earth is equal to G due to moon. Means if you have written this step, you will get the second C mark if you have written this step. And the third mark is answer mark. If you have got right value of x, you will get third mark. So this is how marks will be awarded for this question. In the next video, we will be talking about remaining questions from this paper. And if you have any questions or you have any doubts, please leave your questions in comments and I will answer as soon as possible. And if this video was helpful, so please leave some comments, and if you want me to explain any questions, also you can leave that question in comments. Let's study together, let's improve together. And also on this channel, a lot of videos I will be uploading, not only limited to A-level physics. I will also upload videos about AP physics, and also a lot of videos about competitions such as physics bowl competitions from US, and also BPHO, and also admission test for Cambridge and Oxford, means PAT questions and ANGA questions. Also I will be uploading on my channel, and also I will explain those questions in detail. So please like and subscribe so we can work together and we can improve together. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper question on electric field and magnetic field from May June 2022, paper 4, variant 1. In this question, we will study motion of particle in a region where we have electric field and we have magnetic field. Imagine that we have a horizontal circle. So this one is horizontal circle. In this horizontal circle, mean in this region, we have electric field and also we have magnetic field. So we will study how particle will move in this region. And this concept is very important in physics. and we will study this one by solving past paper questions. Let's study together. Let's improve together. For question number 2, it is given to us a sphere of mass 1.6 times 10 to negative 10 kgs has a charge of 0.27 nanocoulombs, and this is positive charge. The sphere is in a uniform electric field that acts vertically upwards as shown in the side view in figure 2.1. So this figure is a side view. Very important point you need to understand, this is side view. It is also given to us the force exerted on the sphere by the electric field causes the sphere to remain at a fixed vertical height in a horizontal plane. Now you need to imagine horizontal plane. So imagine that we have this circle. So this is a horizontal plane. Or simply you can imagine that we have this book. So this plane of the book, this is horizontal plane, and particle is in this horizontal plane, and particle has fixed height. It means that the particle is not moving vertically up, particle is not moving vertically down. It simply means that forces acting on particle along vertical, these forces are balanced. And this is very important point. We will need this point later to answer this question. For this question, it is also given to us there is a uniform magnetic field in the region of the electric field. It means in the same region we have electric field that is uniform. We also have magnetic field, and magnetic field is also uniform. The sphere moves at a speed of 0.78 meters per second in the horizontal plane. The magnetic field causes the sphere to move in a circular path of radius 3.4 meters as shown in the view from above in figure 2.2. So this view is from above. Means if you look at this horizontal plane from above, what we will see electric field lines out of the page. Imagine that this is the horizontal circle. As you can see, this is the circle, so we can rotate. This is horizontal now. So we are looking from the above. So we will see electric field lines out of the page, and electric field lines are vertically upwards. So this is what is given to us. We can also imagine this one by simply drawing this horizontal circle. Particle is moving in this horizontal circle, and electric field lines are vertically upward. So electric field lines are like this. They are vertically upwards in this horizontal plane. But the particle means the sphere is moving in this horizontal plane. So this is how you can visualize this. Now we need to understand the particle is moving in a horizontal plane. It means that there is kind of force that is forcing this particle to do circular motion. Because if there is no net force on the body will continue moving in a straight line with constant velocity. Or simply you can say in a straight line with constant speed. But this particle is moving in a circle. It means this particle has been forced to move in a circle. It simply means that there is resultant force on this particle acting in this horizontal plane, and that force is due to magnetic field, or simply we can say that is magnetic force. For part A1, we need to determine direction of uniform magnetic field. For this question, it is given to us the particle is moving in a horizontal plane. So in order to find direction of magnetic field, we will draw first of all horizontal circle. In this circle, particle is moving in counterclockwise direction. So we can draw, this is how our particle is moving. So particle is moving in counterclockwise direction. If we take this point, at this point particle is moving to the right, so we can say this is V, and the force acting on this particle is towards center of this circle. Or if I take this horizontal plane here, so in this case means force is into the page. So we can say in this case V is this way, and the force on this particle is into the page. So this is direction of force. Force is into the page. So this is direction of force. Now we need to find out direction of magnetic field. So simply we have to use Fleming left-hand rule. We can use Fleming left-hand rule and we can find direction of magnetic field. Now first of all, you need to align this middle finger with direction of V. So the middle finger is to the right and the force is into the page. So this is force is into the page. So the magnetic field in this case is pointing vertically downwards. So we can write down direction of magnetic field. This is vertically downwards. So this is direction of magnetic field. So magnetic field is vertically downwards. So this is one way you can answer. Now let's try to answer the same question using view from above. In this case, you need to understand electric field is vertically up and direction of electric field from above. This is out of the page. And so this is out of the page. Now if we take this point, at this point particle is moving to the right and direction of force on this particle is vertically up. So this is direction of force. Now in this case, again you see this finger is pointing to the right, means particle is moving to the right. Force on this particle is vertically up. So the magnetic field is into the page. So in this case you will get B, that is into the page. So into the page means that this is vertically downwards because this is view from above. Electric field out of the page means electric field is vertically up. So this is electric field that is vertically up, and magnetic field from above is into the page. So it means this is vertically downwards. It's very important. You need to understand this particle is in horizontal plane, and then you can find direction of magnetic field. For the answer of this question, simply you need to write down vertically downwards. If you write down this one, you will get 1 mark, and that is the mark. For the second part, we need to explain why the motion of the sphere in the horizontal plane is circular. Means why the motion of this sphere is circular. In this case, we need to understand magnetic force is acting perpendicular to velocity. So the angle between magnetic force and velocity of the particle is 90 degrees. If this is true, there is a force that is acting at an angle of 90 degrees to motion of the particle. That force will cause centripetal acceleration. Means particle will move in a circle. So that force will cause centripetal acceleration. And this is what you need to write down for the answer of this question. 1 point you can say force is perpendicular to the velocity, and as force is perpendicular to the velocity and magnitude of the force is constant, so the particle move with constant speed in horizontal circle. Means in this case in horizontal plane. So these 2 points you have to mention in your answer. Let me show you how you can write down the answer. This is how you can write down your answer. You can mention these 2 points. You will get 1 mark if you have written this first point. Then the second mark you will get if you have written the second point. So this is how marks will be awarded for this question. This is very important point. You need to understand when there is a component of resultant force that is perpendicular to the velocity of the particle, that component of force will cause centripetal acceleration and particle will do circular motion. Very important one. You have to be clear about this. For part B, we need to calculate value of uniform electric field. It simply means that we need to calculate value of capital E. For this question, it is given to us the particle is moving in a horizontal plane. It simply means that particle is not moving vertically up, particle is not moving vertically down. Or simply we can say, in this case, forces acting on this particle are balanced. Now we need to understand forces acting on this particle. First thing you need to understand, this particle has a mass. So it means weight is acting vertically downwards, means the gravity is acting vertically downwards. So simply we can say W in this case is equal to mg. And this particle has charge and this particle is in electric field. So the electrical force has to act vertically upwards because there is no any other force acting on this particle. So the electrical force we can say Fe, this one has to be equal to E times Q. Now simply we need to equate these 2 forces. We can say in this case electrical force is equal to W, means weight of this sphere, and electrical force is equal to EQ, weight is equal to mg. We need to find out value of E. So simply we can rearrange. E will be equal to mg divided by Q. Value of m is given. That was equal to 1.6 times 10 to negative 10 kgs. Value of G is 9.81 and charge on this particle was 0.27 nanocoulombs. So simply we can say this is 0.27 times 10 to minus 9. Now if we solve this one, our final answer will be 5.8 newtons per coulomb. Our answer is up to 2 SF because we have least number of SF in raw data, that is equal to 2 SF. So this is how you can write down the final answer. Final answer has to be equal to 5.8 2 SF. This question has 2 marks. The first mark you will get if you have written EQ is equal to mg, and this one is C mark, you will get 1 mark. And the second mark is the answer mark. If you have got the right answer, you will get second mark. For part C, we need to consider magnetic force on the sphere, and we need to show that flux density of the uniform magnetic field is 0.14 Tesla. In this case, hint is given to you, and also you have to use that hint in your answer. Means you have to consider magnetic force on the sphere to calculate magnetic flux density. Now we need to look at motion of the particle. This particle is moving in a horizontal plane, and only force acting on this particle along horizontal is magnetic force. So it simply means that particle is doing circular motion, and force acting on this particle in horizontal plane means along horizontal, that force is magnetic force. So it simply means that centripetal force in this case is provided by magnetic force. So simply we can say in this case centripetal force is provided by magnetic force. So is provided by magnetic force. So very important point, you have to understand this. Centripetal force is not a force by itself. Centripetal force is a resultant force due to other forces. In this case, the resultant force along horizontal means in the horizontal plane is only magnetic force. So we can say in this case FB is equal to FC. So FB is equal to BQV. So this is BQV, and centripetal force is equal to mv squared divided by r. In this case, we need to calculate B, so simply we can cancel this V with this one. So we can rearrange this. We can write down B is equal to mv divided by r times q. Now simply we need to plug in values. Mass of the sphere is given. Mass of the sphere was equal to 1.6 times 10 to negative 10 kgs, and speed of the particle is given, that was equal to 0.78, and radius of the sphere is also given to us. Radius of the sphere is equal to 3.4 meters, and charge on particle was given, that was equal to 0.27 times 10 to negative 9, means nanocoulombs. Now if we simplify this, means simply you put these numbers into your calculator, your final answer has to be equal to 0.14 Tesla. So this is what you need to show, that B is equal to 0.14 Tesla, and this is our final answer. This question has 3 marks. The first mark you will get if you have written FB is equal to FC, and this one is B mark, mean it has to be in your answer. And the second mark is C mark if you have written B is equal to mv over rq. You will get another mark, and that is C mark. And the final mark is answer mark. If you have got the right answer, you will get 3 marks. This is how marks will be awarded for this question. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on thermodynamics from May-June 2022, paper 4, variant 1. In this question, we will discuss some very important points about thermodynamics. And those concepts are very common, or simply we can say those concepts are most frequently asked in past papers. So the understanding of this question is very important. Let's study together. Let's improve together. together. For this question, it is given to us we have a fixed mass of an ideal gas initially at temperature of 17 degrees Celsius, and the gas has a volume of 0.24 meter cubes and pressure of the gas is 1.2 times 10 to 5 pascals. For part A1, we need to state what is meant by an ideal gas. This is very common question. You need to understand how to state ideal gas. In order to state ideal gas, you need to mention few points. The first point you need to mention is a gas is an ideal gas if it obeys ideal gas equation, means PV is equal to nRT. And it has to obey this equation at all values of, means at any value of, or simply you can say at all values of P, V, and T. So if gas obey ideal gas equation at any value of P, V, and T, then that gas is an ideal gas. Then you also need to state these quantities, meaning you need to write down what is P, you need to write down what is V, you also need to write down what is T. So T you have to write down, this is thermodynamic temperature, means temperature in Kelvins. So thermodynamic temperature. So if you write down these points, you will get 2 marks. Now let me show you how you can write down a proper answer. This is how you can write down your answer. If you have mentioned a gas that obeys ideal gas equation, you will get 1 mark, and this is M mark, meaning it has to be in your answer. And the second mark is A mark if you have written P is equal to pressure, V is equal to volume, and T is equal to thermodynamic temperature. You will get second mark. So this is how marks will be awarded for this question. For the second part, we need to calculate amount of gas, means we need to calculate value of N, or simply we can say we need to calculate number of moles of gas. For this question, it is given to us the gas is an ideal gas. So simply we can use ideal gas equation. PV is equal to nRT, and this T in ideal gas equation, this has to be in Kelvin. So first of all, we can convert temperature into Kelvin. T is given to us, that is equal to 17 degrees Celsius. We can convert this T into Kelvins by adding 273. This one is value of temperature in Kelvin. So the unit for this one is Kelvin. Now simply we need to use ideal gas equation. We can rearrange, we can write down N is equal to PV over RT. P in this case is given, that is equal to 1.2 times 10 to 5 Pascal. We can plug in value, and V is given, that is equal to 0.24 meter cube. So this is 0.24. You have to be careful with units, and value of R means gas constant is 8.31. Then temperature we have, that is 17 plus 273 kelvins. Now if we simplify this one, we can get number of moles. In this case, number of moles are equal to 12 up to 2 SF, because the least number of SF in raw data we have 2 SF, so our final answer has to be up to 2 SF. So the answer for this question is 12. This question has 2 marks. The first mark you will get if you have converted temperature into Kelvin, this is C mark, and the second mark is answer mark. If you have got the right answer, you will get second mark. Very straightforward question. Simply you need to understand how to use ideal gas equation. For part B, it is given to us the gas undergoes 3 successive changes as shown in figure 3.1. The initial state is represented by point A. So this one is the initial state. The gas is cooled at constant pressure to point P. Means P here is constant. So simply we can write down P A to B. P is constant by removal of 48.0 kilojoules of thermal energy. So in this case, thermal energy is released, so means it's negative. So we can say this is negative 48.0 kilojoules. The gas is then heated at constant volume to point C. So volume here, delta V is equal to 0. So the change in volume is equal to 0. But temperature of the gas is increasing because gas is heated at constant volume. P is increasing, so temperature is increasing because V is constant. Finally, the gas expands at constant temperature. Very important. Temperature here is constant, so we can simply write down temperature here is constant. Back to its original pressure and volume at point A. During expansion, the gas does 31.6 kilojoule of work. It is also given to us work is done by gas. So we can say work done by gas in this case is equal to 31.6 kilojoules. So this is work done by gas. For this question, it is given to us work done by gas is equal to 31.6 kilojoules. Now we need to understand work done on gas. We need to understand work done on gas is equal to negative of work done by gas. If work is done by gas, it means the gas expands, so gas apply force in upward direction, and displacement is also in the same direction. So we take work done by gas in that case is positive. But if we need to calculate work done on gas, that will be opposite. So in this case, we can say work done on gas is equal to negative 31.6 kilojoules. Let's try to understand a little bit more about this cyclic process. If you look at process between A and B, in this case P is constant. If P is constant, we call this is isobaric process. Now if you look at between B and C, in this process volume of the gas remains constant, and this process is called isochoric. Isochoric process means that volume of the gas does not change. As volume of the gas does not change, so it means in this case work done on gas or work done by gas, that is equal to 0. So simply we can say P times delta V in this case is equal to 0. So in isochoric process, there is no work done by gas and also there is no work done on gas. So very important point. Between C and A, it is given to us temperature remains constant. If temperature remains constant, this process we call this is isothermal process. In isothermal process, temperature remains constant. So in this case, delta T is equal to 0. If change in temperature is 0, it also means that delta U is also equal to 0. Means there is no change in internal energy of the gas. So internal energy, there is no change. Very important point. We will need this one later to answer some questions. And this is also very important point. You need to understand if volume remains constant, work done is equal to 0. So this is very important one. We will be using this one later. For part 1, we need to show that magnitude of the work done during the change AB is equal to 19.2 kilojoules. Means the work done between these 2 points. Now for this one, we need to understand how we can calculate work done. Work done simply is equal to W is equal to P times delta V. In this case, we have value of P, so we can write down V final minus V initial. So this is the change in volume. Value of P is given to us, so at this point you can read value of P, that is equal to 1.2. So simply you can read from here. So this is equal to 1.2. So simply we can plug in value of P, that is equal to 1.2 times 10 to 5. In this case, the final value of V we have, that is equal to 0.08. You have to be very clear with these units. So you have to check these units. For this question, we have meter cube. So simply we can plug in these values. And initial volume you can read from here. So the final you can read from here. So this one is VF and this one is V initial. VI means the V initial, that is equal to 0.24. Now if we solve this one, our final answer will be equal to minus 19.2 kilojoules. kilojoules. So this one is W. Means in this case, gas is compressed. So the work is done on gas, but work done by gas in this case is negative. So the work done by gas in this case is 19.2 kilojoules. So this is negative work done by gas, but work done on gas is compressed, so the work done on gas in this case is equal to 19.2 kilojoules. In compression, work is done on gas, and in expansion, work is done by gas. So simply we can also write down here, in compression, work is done on gas. So work done on gas is positive, but in case of expansion, work done on gas is negative. So we can say work done on gas in expansion is negative, and vice versa is true for work done by gas. Means when work done on gas is positive, work done by gas will be negative, and when work done on gas is negative, work done by gas will be positive. This question has 2 marks. First mark you will get if you have used this formula, then this is C mark, you will get 1 mark, and the second mark you will get if you have got this answer. Sign in this case is not important because question is asking you only magnitude of the work done. So simply you can say W is equal to 19.2 kilojoules. If you have written that, you will get the second mark. And in this case, work is done on gas. So that's the reason we got this is negative because work done by gas is negative. So in this case, we got W, work done by gas, that is negative. So if you calculate work done on gas, that one will be positive. For the second part, we need to complete table 3.1 to show the work done on the gas, thermal energy supplied to the gas, and the increase in internal energy of the gas. For each of the changes A, B, B, C, and CA. First of all, if you look at A to B, in this case we have already calculated work done on gas, because between A to B is compression, so the work done on gas is equal to 19.2 kilojoules, and this value we have calculated in part 1. For A to B, it is also given to us thermal energy is released, so this amount of thermal energy is released. So thermal energy supply is negative, so we can say thermal energy in this case is negative 48.0 kilojoules. Now we need to calculate increase in internal energy of the gas. So we have to use first law of thermodynamics. According to first law of thermodynamics, delta U is equal to Q. This is the thermal energy supplied plus work done on gas. So this is work done on gas, and this is thermal energy supplied. In this case, thermal energy is released, so this one has to be negative 48.0 kilojoules. Work done on gas, that is equal to 19.2. So the change in internal energy, that one will be equal to negative 28.8. So it simply means that internal energy decreases. Now we need to plug in values here. So from A to B, we can say work done on gas is equal to 19.2 kilojoules, and increase in internal energy is negative 28.8. Now let's go to BC. Between BC, work done is equal to 0 because in this case change in volume is equal to 0. So simply we can plug in here work done is equal to 0. Now the second part is tricky part. You need to understand between C to A, temperature remains constant. Delta T is equal to 0. So it simply means that change in internal energy between C and A, that is also equal to 0. And that is the tricky part. You have to be very clear about that. Now if we need to calculate change in internal energy between CA, so we can say the change in internal energy from C to A, or you can say from A to C, is the same because change in internal energy in this case is equal to 0. So we can say delta U from A to C. That one has to be equal to delta U from A to B plus delta U from B to C. In this case, we have delta U from A to C or from C to A, because change in internal energy in this case is equal to 0. We can simply say this is 0. Delta U from A to B we have just calculated, that is equal to minus 28.8. So we can calculate delta U between B and C. So delta U between B and C in this case has to be equal to 28.8 kilojoules. So this is value of delta U between B and C. So we can write down delta U is equal to 28.8 kilojoules. Now we have value of delta U, so we can use first law of thermodynamics again, and we can calculate value of Q. In this case, we have delta U that is equal to 28.8. Q supplied we need to calculate plus work done on gas. Work done is equal to 0. So it means Q supplied is also equal to 28.8 kilojoules. And this part was most tricky one. And next one is quite straightforward one. Between C to A means from C to A, change in internal energy is equal to 0. Now we need to calculate thermal energy supplied to the gas. So we have to use first law of thermodynamics again. Now for this process, we have Ca, change in internal energy, that is equal to 0. And we have work done on gas, that is equal to minus 31.6 kilojoules. So the Q supplied in this case has to be equal to 31.6. Mean in this case, change in internal energy is equal to 0. So the heat supplied has to be equal to work done on gas. So simply we can say this is equal to 31.6. Work done on gas is negative. So heat has to be supplied. And if heat is added to the system, that is taken as positive. Otherwise, simply you can see from this equation. So that's all what you need to do for this question. If you got all these values right, you will get 5 marks. This question has 5 marks in total. I have explained you this question in detail. If still you have any doubts or you have any questions, please leave your questions in comments and I will answer as soon as possible. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on simple harmonic motion from May June 2022, paper 4, variant 1. In this question, we will discuss some very important concepts about simple harmonic motion. And those concepts are most frequently asked in past paper questions. In order to get maximum benefit from this video, first of all, pause the video, do the question by yourself, and then check the solution. This is the best way to get maximum benefit from videos. Let's study together. Let's improve together. For question number 4, it is given to us a pendulum consists of a bulb, means small metal sphere. As you can see here, we have one small metal sphere at the end of the string. And this small metal sphere is called bulb, attached to the end of a piece of string. The other end of the string is attached to a fixed point. This point is the fixed point. The bulb oscillates with small oscillations. Very important point. If angle of oscillation means the angle with vertical, if that angle is less than 15 degrees, it means the motion of this pendulum is simple harmonic motion. So we can use principles of simple harmonic motion. About its equilibrium position as shown in figure 4.1. The length L of the pendulum measured from the fixed point to the center of the bulb is 1.24. Means L is from the fixed point to the center of this bulb, and that L is equal to 1.24 meters. For this question, it is also given to us the acceleration A of the bulb varies with its displacement x from equilibrium position as shown in figure 4.2. For part A, we need to state how figure 4.2 shows that motion of the pendulum is simple harmonic motion. So we need to understand conditions for simple harmonic motion, and then we will apply those conditions to figure 4.2 to find out whether the motion of the pendulum is simple harmonic motion or not. So let's try to understand conditions for simple harmonic motion. Conditions for simple harmonic motion. The first condition is A is directly proportional to minus x. It means that A and x, so simply we can say A and x, they are directly proportional. So one thing we can say from here, A is directly proportional to minus x. It means A and x are directly proportional. It simply means that when one is increasing, other is also increasing, and vice versa is also true. So they are directly proportional. So simply we can say when x is increasing, acceleration will also increase, and when x is decreasing means the displacement, x is the displacement here. When displacement is decreasing, acceleration will also decrease. So this is what A is directly proportional to x is telling us. Now let's try to understand the significance of this minus sign. The minus sign is telling us when A is positive. So let me write down here minus sign. This minus sign simply tells us when A is positive, means when A is positive, x has to be negative. And when A is negative, x has to be positive. It simply means that A and x, they have opposite directions. So simply we can say they have opposite directions. And this one you can also understand with the help of this equation. A is equal to minus omega square x. So any object which is doing simple harmonic motion, they have to satisfy this equation, and this is condition for simple harmonic motion. And acceleration has to be, for simple harmonic motion, acceleration has to be directed towards equilibrium. So this is also condition for simple harmonic motion. So we can say acceleration has to be directed towards equilibrium. So these are the conditions for simple harmonic motion. Now let's try to find out is the motion of this pendulum is simple harmonic motion or not, with the help of this figure. In this figure you can see, first of all, A and X, they are directly proportional because it's a straight line. So this is a straight line through the origin. It simply means that they are directly proportional. So first thing we can say that as it is a straight line and passing through origin, we can say straight line through origin, it simply means that A is directly proportional to X, and the gradient of this one is negative. Negative means that they are in opposite direction. So second point you can say, as the gradient of this graph is negative, it simply means that A and X, they have opposite directions. So they have opposite directions. That's all what you need to write down for this question. And this figure 4.2 is satisfying conditions for simple harmonic motion. So the motion of this simple pendulum is simple harmonic motion. And this question has 2 marks. If you write down these 2 points, you will get 2 marks. The first mark you will get if you have written straight line through origin, and it means that A and X, they are directly proportional. The second point, if you have said negative gradient, and negative gradient is telling us that A and X, they are in opposite directions, you will get the second point. And this question has 2 marks. For part B1, we need to use figure 4.2 to determine angular frequency omega of oscillations. We have already discussed motion of pendulum is simple harmonic motion, and this line is a straight line. So we can use equation for simple harmonic motion to link A and X together. A is equal to minus omega squared X. As this is a straight line, we can compare this one with straight line equation. Means we can say y is equal to mx. And in this case, m is equal to minus omega squared. So simply we can write down, in this case, gradient is equal to negative omega square, or simply we can say in this case omega square is equal to negative of gradient. So in order to calculate omega, we need to calculate gradient first of all. So let's try to calculate gradient of this graph. In order to calculate gradient, you can take any 2 points on this straight line. I will take 1 point at origin, then the second point I will take here, and the coordinates of this point, we have 0.05 5 comma minus 0.4. So we can calculate gradient. So in this case, we need to write down this is minus 0.4. I mean, this is y2 minus y1. y1 is equal to 0 divided by, we have 0. This is value of x2 minus x1. So we can solve this one and we can find out value of gradient. So in this case, value of gradient will be equal to minus 0.4 divided by 0.05. Now we can plug in this value here. If we take minus of that, we have minus 0.4 and this is divided by 0.05. So simply we can write down minus will be cancelled with minus. So we have 0.4 means you multiply minus with minus, you will get positive sign. So here we have divided by 0.05. Then this one is equal to omega square. So this is value of omega square. But we need to calculate omega. So we can write down here omega. This one will be equal to 0.4 divided by 0.05. If we take square root on both sides, so we will get omega. So omega in this case will be equal to 2.8 radians per second up to 2 SF. So the answer for this question is 2.8 radians per second. This question has 2 marks. You will get the first mark, the C mark, if you have written omega square is equal to negative of gradient. You will get 1 mark and that is C mark. And the second mark you will get if you have got the right answer. And this is how marks will be awarded. For the second part, it is given to us the angular frequency omega is related to the length L of the pendulum by this equation. And it is also given to us K is a constant. Use your answer in B1 to determine K. Give a unit with your answer. So for this question, you need to write down the unit and also you need to write down the magnitude of K. So first of all, let's try to understand how we can calculate K. In order to calculate K, we can rewrite this equation. We can write down omega is equal to square root of K over L. Now, if we square both sides, we can write down omega square. This one will be equal to K over L. From here, we can say K will be equal to omega square times L. We have already calculated value of omega in part B1. Omega was equal to 2.8 and L is equal to 1.24. This is given in this question. Now simply we need to multiply. If we multiply this one, our final answer will be 9.7. Now we need to understand how we can write down the unit. The unit of omega is radian per second. So this is radian per second square. And the unit of L is meter. So we can write down our final answer in SI units. That will be equal to meters per second per second. So using SI based units, our answer is 9.7 meters per second per second. Radian is not SI based unit. So simply we can write down here K is equal to 9.7 and the unit of this one is meters per second per second. And this question has 2 marks. The first mark you will get if you have written K is equal to omega square L, you will get 1 mark and that is C mark. And the second mark you will get if you have got the right answer with units, you will get A mark. So this is A mark. For part C, it is given to us while the pendulum is oscillating, the length of the string is increased in such a way that the total energy of the oscillations remains constant. Total energy remains constant. So this is key concept. You need to answer this question. Total energy remains constant. For this question, we need to suggest and also we need to explain qualitative effect, means we don't need calculations of this change on the amplitude of oscillations. Now, first of all, let's try to understand if the total energy remains constant, what is effect on amplitude? So if you look at this pendulum at this point, the energy of this oscillator is maximum. Means energy at this point, the total energy is equal to kinetic energy maximum. And kinetic energy maximum will be equal to 1/2 mv max, means the maximum speed, V max square. Now we can simply write down here total energy that is equal to kinetic energy maximum kinetic energy maximum, and kinetic energy maximum is equal to 1/2 mv max square. But you need to understand maximum speed Vmax for simple harmonic motion. We need to understand Vmax is equal to A times omega. A is the amplitude of oscillations. So simply we can replace V with A omega. So we can write down here Vmax is equal to A omega square. Now if we simplify this, we will get 1/2 m A square omega square. Now we need to understand what is the effect of L on omega. So we can rewrite omega square. This is equal to K over L. If L increase, it means omega has to decrease. So it means that omega in this case is decreasing. If omega decrease, it also means that A has to increase. Means the amplitude has to increase because 1/2 m is constant and total energy of oscillations, that is also constant. It simply means that if omega decrease, A has to increase because total energy remains constant. So this is the main concept you need to understand. Now we can also understand this one. Omega is equal to 2 pi over T. So if omega decrease, time period will increase. So it simply means that before this pendulum was oscillating very fast like this. Now omega has decreased. So time has increased. So it will oscillate slowly. That its amplitude of oscillation will be greater than before. So that's all what you need to write down for this question. So first thing you can say in this case, as L increases, we can say as L increases, omega decreases. As L increases, omega decreases. So this is first thing you can write down. Omega decreases. As omega decreases, amplitude increases. So we can say, so amplitude increases because total energy is constant. So amplitude increases as total energy is constant. As total energy, we can say, remains constant. Or simply you can say as total energy is constant. So that's all what you need to write down for this question. This question has 2 marks. You will get the first mark if you have written as L increases, omega decreases. You will get 1 mark, and that is M mark. Means this has to be in your answer. This point has to be in your answer. Then this is the explanation, so it has to be in your answer. Otherwise you will not get any mark for this question. And the second mark is answer mark. If you have written amplitude increases, you will get the second mark, and this is answer mark. So you have to write down the statement. This one is the statement and this one is the explanation. So if you write both of them, you will get 2 marks. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on rectification and capacitance from June 2022, paper 4, variant 1. In this question, we will discuss these 2 main topics, rectification and capacitance, in depth by solving past paper question. This question will help you to understand rectification and capacitance in depth. Let's study together. Let's improve together. For question number 5, it is given to us. Figure 5.1 shows 4 diodes and a load resistor of resistance 1.2 kilo ohms connected in a circuit that is used to produce rectification of an alternating voltage. For part A1, we need to state what is meant by rectification. Rectification simply is a process. With the help of this process, we can convert AC into DC. So simply we can say converting AC into DC is called rectification. So we can say converting AC into DC is called rectification. Converting AC into DC. So this is how you can simply state what is meant by rectification. And this question has 1 mark, that is B mark. If you simply write down converting AC into DC is called rectification, you will get 1 mark. For the second part, we need to state type of rectification produced by the circuit in figure 5.1. If you look at this figure, you can see we have 4 diodes. If we have 4 diodes, this is called full wave rectifier. So we call this one full wave rectifier. Full wave rectifier. Now let's try to understand about types of rectifications, and then we will answer this question. There are two types of rectifications. We can simply write on here. Types of rectification. The rectification has two types. One we call is half wave rectification. Half wave rectification. And the second one is full wave rectification. Full wave rectification. Half wave rectification we can achieve by just using one diode. So we can achieve this one by just using one diode in a circuit. One diode. And this half wave rectification, the curve of this one, if we draw voltage against time, means time on x-axis, we will get curve, means we will get this half cycle, there will be voltage across load resistor, and half of the cycle there will be no voltage across load resistor. So this is shape of half wave rectification. On other hand, full wave rectification we can achieve by using two diodes in a circuit. By using two diodes, or we can achieve this one by using 4 diodes. 2 or 4 diodes. We can achieve full wave rectification. And if we look at voltage against time graph for full wave rectification, so here we have voltage and here we have time. So the voltage across the load resistor, we will see like this, means we have voltage that is changing with time, and then we have voltage that is again changing with time, and so on. Let's try to compare these two types of rectification. In case of half wave rectification, you can see half of the cycle there is no voltage across load resistor. But in case of full wave rectification, there is always voltage across load resistor, but that voltage is changing with time. Now if you look at similarities between half wave and full wave, you can see in case of half wave voltage is always positive, and in case of full wave voltage is also always positive. It simply means that current will enter load resistor always from one side. Now simply you can say direction of current in load resistor will not change with time. In this case we have 4 diodes. It simply means that this one is full wave rectification. So this one is full wave rectification. This question has only 1 mark. If you have written full wave rectification, you will get 1 mark, and that is B mark. For part B, it is given to us a sinusoidal alternating voltage Vin is applied across the input terminals X and Y. The variation with time t of Vin is given by the equation. Vin is equal to 6.0 sine of 25 pi t. Vin is in volts and time is in seconds. For part B1 on figure 5.1, we need to label the output terminals P and Q with the appropriate symbols to indicate the polarity of the output voltage. Now let's try to understand first of all how we can indicate the polarity. Let's try to understand this one with one very simple example. Imagine that we have a battery, and this battery has a resistor that is connected across this battery. So this one is the resistor. So this terminal of the battery is positive and this one is negative. So conventional current will flow from positive terminal of the battery and it will pass through this resistor. Now we need to understand this side, and this side is current entering side. Current entering. So we have current entering side, and current entering side is connected with positive terminal of the battery. So we will mark this side positive, and current leaving side we can write on here, current leaving side, current leaving side. And that one is connected with negative terminal of the battery. And we will use this understanding to mark the polarity of this resistor, means the polarity of the output. So in this case, when this terminal is positive, you will see current will flow like this. And when current will reach at this point, current cannot go this way because this is connected in reverse biased. So this one is connected in reverse biased. So current cannot flow this way. So current will flow like this. After reaching at this point, current cannot pass through this diode because this is connected in reverse biased. So we can say this one is connected in reverse bias. So current simply will flow like this. Current will go this way and current will enter this resistor from Q. So this side has to be positive. And current will pass through this resistor and come back like this. So it cannot go this way because this potential, we can say, let's say this potential is V1 and potential at this point is V2. So in this case, V1 is greater than V2. So current only flow from high to low. So current will not flow this way. So current will go through this diode and come back to this power supply. So this is how current will flow. Let me also use line here, solid line here, so you can see what is happening in this case. Now let's try to understand this one using a different color. So I will be using red color now. Now imagine that when this side is positive. So in this case, current will flow like this. I will be using arrows here. Current will flow like this. Current will go here. When current will reach this terminal, current has two ways to go. It can go this way or current can go this way. In this case, current will go this way because this is connected in reverse biased. So current cannot flow through this diode. So current will go this way and current will flow like this. And finally, current will enter from this side and pass through this resistor, and then current will reach at this junction. Now we need to understand which way current will flow. You need to understand, if again I say this is V2 and this one is connected with positive terminal of the power supply, let's say this one is V1. In this case, V1 again is greater than V2. So current cannot pass through this one because current cannot flow from low to high potential. So current will flow this way, and this is how current will flow. Current cannot flow through this diode as well because this side of the diode is at higher potential. Simply we can say this is at higher potential and this one is at lower potential. So current cannot pass through this diode. So that's the reason current will go this way. Means current will go towards negative terminal. So when this is positive, this is negative, and when this was positive, this was negative. Now we are talking about when this side is positive, so this side is negative. So this is how current will flow. For the sake of this question, simply you need to mark this side is positive and this side is negative. So this is how you can mark. Now let me explain you this one using a different method, or simply you can say shortcut. So first of all, I will clean this one and then I will explain you one shortcut. If you look at these diodes, look at this junction and also look at this junction. At this junction, you can see these diodes, they converge. So they converge. If we compare here, so they converge at this point. So we can say they converge at this point, and this side has to be connected with positive. So this is positive terminal of the output, and this side where they diverge, you can see at, let me mark this point. Let's say this is point 1 and let's say this is the second point. At this point, you can see at the second point, you see they diverge, mean they go away from each other. They diverge like this, go away. And that side where they diverge, that one has to be connected with negative. So this one is negative terminal of output. And the side where they converge, that one has to be connected with positive. So this is how you can figure out what is positive terminal of output voltage and which one is negative. So this one has to be positive because this is connected with this point where diodes converge, and the other is diverge, where diodes diverge. So this is how you can find out. For part 2, it is given to us the magnitude of the output voltage Vout varies with time t as shown in figure 5.2. On figure 5.2, we need to label both of the axes with the correct scales. Use the space below for any working that you need. For this question, it is given to us V in is equal to 6.0 sine of 25 pi t. Now if we compare this one with journal equation, we can simply write down V as a a function of t, this is equal to v peak, or simply you can say this is v naught sine of omega t. So this is sine of omega t. Now from here we can find out the peak value of the voltage. Peak value of the voltage is, simply we can say V peak is equal to V naught, and V naught is equal to 6.0 volts. Omega in this case has to be equal to 25 pi. So we can say omega is equal to 25 pi. We need to find out time period. So omega is equal to 2 pi over time period. From here we can say time period will be equal to 2 pi over omega, and value of omega is equal to 25 pi. So this is equal to 25 pi. Pi we can cancel with pi, and we left with t is equal to 2 divided by 25. Now if we solve this one, value of time period we will get that is equal to 0.08 seconds. So this is value of time period. In this case, one time period is this. So we can label this one. This is 0.08, and this one will be 0.06, and this one will be 0.04, and here we can label 0.02. Now the peak value of the voltage is given. So peak value of the voltage is 6.0, and this is halfway. So this one we can say will be 4, and this one we can say will be 8.0. So this is 4.0. So this one we can label is 0. So this is how you can label axis. Let's try to understand a little bit more about time period. How do we know that we need to label time period at this point? The reason is that over alternating input voltage, this is the time period of alternating input voltage, and over alternating input voltage has time period that is equal to 0.08 seconds. So this is over alternating input voltage. So that's the reason we have labeled time period here, not here. For part C, it is given to us the output voltage in B is smoothed by adding a capacitor to the circuit in figure 5.1. The difference between the maximum and minimum values of the smoothed output voltage is 10% of the peak voltage. On figure 5.1, we need to draw the circuit symbol for a capacitor, showing the capacitor correctly connected into the circuit. You need to understand, for smoothing, when we connect capacitor has to be connected across load resistor, means in parallel. So here we need to connect over capacitor. This is how capacitor has to be connected. For this question, simply you need to draw the symbol for capacitor, and this one has to be connected across load resistor. This question has only 1 mark. If you have drawn this symbol, you will get 1 mark. For the second part on figure 5.2, we need to sketch the variation with time t of the smoothed output voltage. But for this question, it is given to us the difference between the maximum and minimum values of the smoothed output voltage is 10% of the peak voltage. Peak voltage we have already discussed that peak voltage is equal to 6.0 volts. We can simply say in this case V max is equal to 6.0 volts. So the V minimum, that has to be equal to 90% of the peak voltage, 90% of V max. Or simply we can say 0.90 multiplied by 6.0, and this one will be equal to 5.4 voltage. So this is the minimum value of the voltage across load resistor, and this one is the maximum value. In order to sketch the curve, first of all we need to label Vmax, and also we need to label Vmin, and then we can sketch the curve. First of all, we need to understand Vmax is the peak value of the voltage, and Vmax is equal to 6.0. Now we need to understand the difference between these two, mean difference between 4 and 6. Difference is equal to 2 volts. We can simply write down 2 volts, and 2 volts is divided into 5 parts. We can divide this one by 5, means by 5 boxes. So in this case we will get 0.4 volts per small box, So it simply means that this is 4, so here we will have 4.4, we will have 4.8, and here we will have 5.2, and here we will have 5.6. So the 5.4 is between 5.6 and 5.2. Simply we can draw a line. So we can simply draw the line. So the line we need to draw between 5.2 and 5.6. So this is how we can draw the line. So our minimum voltage should not be lower than this one. Maximum voltage across the load resistor is 6, and minimum voltage across load resistor is 5.4. Now simply we need to connect these 2 points using a curve. So this is how you can connect using a curve. So between these 2 points, capacitor will discharge. So we can say capacitor will discharge between these 2 points. And then again capacitor will charge. Means the battery voltage will increase across capacitor and capacitor will start charging. So in this region, capacitor will charge because the voltage across capacitor will increase. So capacitor will start charging. And again capacitor will discharge because the battery voltage across the capacitor will start decreasing. So capacitor will discharge. So this is how you can sketch. Again here capacitor will start charging. So between these 2 points capacitor will charge. So we can simply say capacitor will charge. And here capacitor will again discharge. So we can draw the line. Capacitor will discharge. And here you can also draw capacitor will discharge. So we can start from here. Capacitor will discharge and capacitor will charge again. So this is how you need to sketch the curve. If you draw simply a straight line between these 2 points, that is also acceptable. But the better way is to draw a curve because capacitor is discharging. And discharging of capacitor is not a straight line. If we have voltage and we have T on x-axis, so the capacitor will discharge and capacitor will follow this curve. In this case, V as a function of time is equal to V naught e to the power of minus t over RC. So this has to be exponential decay curve. So it's better to draw the curve, not a straight line. For the last part, we need to calculate capacitance of capacitor. In order to calculate capacitance of capacitor, we need to understand discharging of capacitor. And discharging of capacitor is part of new syllabus. Let's try to understand, first of all, about discharging of capacitor. So simply we can say discharging. When a capacitor is discharging and you need to find out value of potential difference across capacitor at any given time t, you can simply use this equation. You can write on V as a function of time is equal to V naught e to the power of minus t over RC. Let's say we need to find out value of V after time t, then simply you can write down V naught, the time taken for V naught to become Vt, that time is t, and that time is here. So this is the time taken, and this is the value of V after time t. In this case, we have peak value that is 6.0, and after time t, we have value of V that is equal to 5.4. So simply we can write down here we have 5.4 after a certain period of time, and the peak value we have that is 6.0 times e to the power of minus t over RC. So we can simplify this. We can write down this is 5.4 divided by 6.0 times e to the power of minus t. We don't have value of t, and this one has to be divided by RC. Value of R is given, that is equal to 1.2. This is the resistance of the circuit, 1.2 times 10 to 3 ohms, and this is multiplied by C. Now we need to find out value of t, and value of t is the time taken for this capacitor to discharge from 6.0 to 5.4, and that time you can find from here. So the time taken in this case is 0.054 minus 0.02, and this time taken we can write down here. We can say t is equal to 0.054 minus 0.02, and this one is equal to 0.034. So this is the time taken for the voltage to drop from 6 to 5.4, from 6 to 5.4. So this is the discharging time. So simply we can write down here this is 0.034. So we can clear this box and we can write down the value here. And this is 0.034. Now, if we take ln on both sides, we can say ln of 5.4 divided by 6.0. This one will be equal to minus 0.034 divided by 1.2 times 10 to 3 times C. Ln of E is equal to 1, so that's the reason we have cancelled E, because ln of E is equal to 1. So ln of E is equal to 1. Now we need to find out value of C, so we can simply write down C will be equal to minus 0.034 divided by 1.2 times 10 to 3 times ln. I'm just writing this value, but you can use calculator. You can find out ln of 5.4 divided by 6.0. So here you need to write down ln of 5.4 divided by 6.0. And if you solve this one, your final answer has to be equal to 2.7 times 10 to 4 farads. And this is the final answer. Our answer has 2 SF because in the raw data we have 2 SF. This one has 2 SF, this one has 2 SF, and here we have 2 SF. Means the minimum value in given data is 2 SF. So our final answer also has to be up to 2 SF. So our final answer is 2.7 times 10 to negative 4 farads. And this is the final answer. This question has 3 marks. The first mark you will get if you have got the right value of discharging time, or if you have got right value of minimum voltage across capacitor. And the second mark you will get if you have used this formula and you have plug-in values. So this one is the first C mark and this one is the second C mark. And the last mark is answer mark. If you have got the right answer, you will get this mark. This is how marks will be awarded for this question. That's all for this video and also for this question. I'll see you in next video, and the next video will be coming very soon. I will be explaining remaining questions in this paper. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electromagnetic induction from May June 2022, paper 4, variant 1. In this question, we will talk about magnetic flux. We will discuss how to define magnetic flux. We will also talk about magnetic flux linkage, and we will discuss how to calculate magnetic flux linkage. After magnetic flux linkage, we will talk about induced EMF, and we will also discuss some other important points about electromagnetic induction. And we will discuss these topics by solving past paper questions. Let's study together. Let's improve together. For question number 6, part A, we need to define magnetic flux. And this question is very common in past papers. Most of the time, they will ask you to define magnetic flux. So you need to understand how to define magnetic flux in a proper way. Let's try to understand how we can define magnetic flux in a right way. We use symbol for magnetic flux. This is phi, and magnetic flux is equal to BA cosine of theta. And theta is the angle between magnetic flux density, and this is the angle between area normal vector. So you need to understand A in this case, this is area normal vector. Area normal vector. Area normal vector. So in this case, if you look at this ring, in this case, area normal vector means area that is means the vector that is normal to this area. That vector we call is area normal vector. Vector normal to the area of this lobe. That is area normal vector. So this is area normal vector. In this case, flux will be equal to BA cosine of angle between A and B. Angle in this case is equal to 0 degrees. So simply flux will be equal to B times A. So this is how you can calculate flux for this one. Now let's try to calculate flux for this second case. In this case, you can see area normal vector. So this is the area normal vector. And in this case, this is B. So this one is B. You can see in this case, there is angle between these two, and angle is theta. So flux in this case will be equal to B cosine of theta. Means this is B. We can resolve this one into two components. So this is one component and this one is the second component. And this component is B cosine of theta. And this component is in parallel with area normal vector. So we have B cosine of theta times, you can write down A. Simply you can write down BA cosine of theta. And theta is the angle between A and B. So simply in this case, flux is equal to BA cosine of theta. So you need to understand, you need to take component of magnetic flux density that is parallel to the area normal vector. So this is how we can calculate. So simply we can say flux is equal to product of magnetic flux density and area. And area you need to take the area, imagine that this one is the loop and this is the flux. So the angle between this B and this plane angle is 90 degrees. So another way you can say area that is perpendicular to the magnetic field, that area you have to consider. So let me explain to you how you can write down the answer. This is how you can write down your answer. So first point you can say product of magnetic flux density and area, simply BA. So this is BA. And you have to explain in this case area that is perpendicular to the magnetic field. Means if you have, this is the plane, imagine that this is the plane, so this is the area and magnetic flux is this way. So you have to take area that is perpendicular to the magnetic field. So we have to take this area that is perpendicular to the magnetic field. So this is the magnetic field and this is the area, and this area is perpendicular to the magnetic field. So we have to take this area. Otherwise you can say you have to consider the component of magnetic flux density that is in parallel with the area normal vector, as we have discussed in this case. So this is how you can define magnetic flux. This question has 2 marks. First mark is M mark. If you have written product of magnetic flux density and area, you will get 1 mark, and the second mark you will get if you have explained which component of magnetic field you need to consider. You will get the second mark. Simply you can say area that is normal to the magnetic field. You will get the second mark, and that is A mark. For part B, it is given to us a square coil of wire of side length 12 centimeters consists of 8 insulated turns. The coil is stationary in a uniform magnetic field. The plane of the coil is perpendicular to the magnetic field, as shown in figure 6.1. It is also given to us the flux density of the magnetic field varies with time, as shown in figure 6.2. For part 1, we need to determine magnetic flux linkage. Inside the coil at time t is equal to 0.60 seconds. We also need to give a unit with over answer. This question is simply asking us to calculate magnetic flux linkage. Magnetic flux linkage. And magnetic flux linkage is equal to NBA cosine of theta. And theta is the angle between area normal vector, and this is the angle between magnetic flux density. But for this question, it is given to us that plane of the coil is perpendicular to the magnetic field. It simply means that in this case, the angle between B and A angle is equal to 0 degrees. So simply we can say in this case, magnetic flux linkage is equal to NBA, because cosine of 0 is equal to 1. So simply we can write down here cosine of 0 is equal to 1. Now simply we need to plug in values here. N is the number of turns. In the question it is given to us there are 8 number of turns. So this is 8. Magnetic flux density we have to calculate at time 0.6. So we can read from the graph. Magnetic flux density is equal to 400 millitesla. 400 milli. So we have to multiply with 10 to negative 3 in this case. A is the area of the coil. Side length of the coil is given. That was equal to 12 centimeters. So we can say 0.12. we have to calculate area of square, so we have to multiply with 0.12 again. Simply we need to calculate. If we calculate this one, our final answer has to be 0.046, and the unit of magnetic flux linkage or magnetic flux is simply Weber, WP. So this is our final answer, 0.046, and the unit is Weber. So this is how you can answer this question. This question has 3 marks. The first mark you will get if you have written this formula, and this is the C mark. And the second C mark you will get if you have plugged in these values, and the last mark you will get if you have got the right answer, and that mark is answer. For the second part, we need to state how figure 6.2 shows that the electromotive force induced across the terminals between time t is equal to 0 and time t is equal to 0.60 second is constant. Let's try to understand this one with the help of EMF. EMF is equal to n d phi by dt. If we expand flux, we can write down flux is equal to BA. In this case, simply we will write BA because plane of the coil is perpendicular to the magnetic field. So we no need to consider angle in this case because angle is 0. So the cosine of 0 is equal to 1. In this case, area of the coil is constant. So we can take this out. We can say this is NA dB by dt. And dB by dt is equal to gradient of this curve. So simply we can say d by dt, this one is equal to gradient. And so simply we can write down in this case induced EMF is equal to NA times gradient, and gradient in this case is constant as this is a straight line. We can say gradient is constant in this case because it's a straight line. It's a straight line. As gradient is constant, it also means that induced EMF is also constant. If gradient is constant, A is constant, N is constant, it means induced EMF is also constant. So simply we need to write down here because it's a straight line graph. So induced EMF is constant. And this question has only 1 mark. If you have written straight line, you will get 1 mark. And this is the B mark. For our third part, we need to calculate the magnitude of E. In order to calculate magnitude of E, we need to understand induced EMF is equal to rate of change of magnetic flux linkage. And we have discussed this point before. So we can simply say this is rate of change of magnetic flux linkage. And rate of change of magnetic flux linkage, we can also write down NA because A is constant, N is constant. We can just take out. So we can simply write down here. So this is dB by dt, and dB by dt, this is equal to the gradient of this graph. So simply we can plug in values here. N is given to us, that is equal to 8. Area of the coil is 0.12 times 0.12. Now we need to calculate gradient. So we will take this point and we will take this point. So we can write down value of B at time 0.6, that is equal to 400 millitesla. So we have to multiply with 10 to negative 3 minus 0 divided by change in time 0.60 minus 0. Now simply we need to solve this one. If we solve this, we will get 0.046. This is the magnetic flux linkage and the time is 0.6. And our final answer in this case will be equal to 0.077 volts. And this is magnitude of induced EMF. So simply we need to write down here 0.077 volts. This question has 2 marks. The first mark you will get if you have written induced EMF is equal to rate of change of magnetic flux linkage. You will get 1 mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For part C, it is given to us the procedure in B is repeated, but this time the terminals of the coil are connected together. These terminals are connected together. For this question, we need to state and explain the effect on the coil of connecting the terminals together during the change of magnetic flux density, as shown in figure 6.2. First of all, let's try to understand what will happen if you place a conductor inside changing magnetic field. Imagine that we have one ring, but this is not a complete ring. And if we place this one inside changing magnetic field, and the magnetic field means the external magnetic field is into the page. For this question, it is given to us that magnetic flux means the magnetic field is increasing with time. In this case, if the ring is not a complete cycle, in this case, only EMF will be induced, but induced current will be equal to 0. Means in this case, no current will flow in this ring if ring is not a complete circle. Now imagine that we have external magnetic field that is still into the page. So we can write down here, we have external magnetic field that is into the page. And this external magnetic field is increasing with time. Means the magnetic flux is changing with time. If we place a complete circle, means a complete ring inside this changing magnetic flux, so there will be induced EMF and also there will be induced current. Now current can flow, but in this case current cannot flow. Now let's try to answer our question. For the question it is given to us, we have a complete square. As you can see here, we have this complete square. So this is the complete square, and the terminals are connected now, so it means this is a complete square. And this complete square is inside changing magnetic field, and magnetic field is into the page, and this magnetic field is increasing with time. And that one you can see in the graph, it is given B is increasing with time. So we have external magnetic field that is into the page, and this external magnetic field is increasing with time. So according to Lenz's law, this square will oppose the change in flux. So how it can oppose the change in flux? It will produce its own magnetic field in opposite direction to external magnetic field. So in this case, direction of induced magnetic field has to be out of the page because it has to be opposite to external magnetic field. So current will flow in this square in such a way that it will produce its own magnetic field that is out of the page. Now if the magnetic field is out of the page, we can find direction of current. So you have to use right hand grip rule. Magnetic field is out of the page, so you have to curl your finger, and your fingers will give you direction of current. So fingers will give you direction of current, and in this case direction of current will be anti-clockwise. So it simply means that current will flow in this way. Current will flow like this. So this is direction of induced current, and we have found direction of induced current by using right hand grip rule. Now in this case you need to understand current is flowing in the coil. As current is flowing in the coil, so simply we can say there is I induced in the coil. I induced in the coil. As there is I induced in the coil, and coil has its own resistance, so it simply means that energy will be dissipated in the coil. It simply means that electrical energy will be converted into thermal energy. So we can say energy will be dissipated. As energy is dissipated, means electrical energy has been converted into thermal energy. Due to thermal energy, temperature of the coil will rise. So we will simply say temperature of coil will rise, mean coil will get hot. And this question has 3 marks, so if you mention these points you will get 3 marks. Means the 1 point you can say I induced. So in this case EMF will cause induced current, and as current will flow in the coil, energy will be dissipated because work has to be done for the flow of current. As energy is dissipated due to thermal energy, means electrical energy is converted into thermal energy, temperature of the coil will rise. So this is one way to answer this question. Later I will explain you another method as well. So let me show you how you can write down a proper answer. This is how you can write down your answer. You can say induced EMF causes current in the coil. So this one has 1 mark. If you have written this one, you will get 1 B mark. And the second mark you will get if you have written current causes dissipation of energy in the resistance of the coil, you will get another B mark. And the last mark you will get if you have mentioned temperature of the coil rises, you will get an other B mark. So this is one way you can explain this question. Let me explain to you the second way based on forces. Now you need to understand, as current will flow in this coil, and this coil is placed inside external magnetic field. So we need to understand motor effect now, mean how forces will act on this coil. First of all, imagine that we have only this piece of wire, and this wire is placed inside external magnetic field. So we can draw our external magnetic field, and we can place this wire inside this external magnetic field. Now you can use your left hand rule and you can find out direction of force on this piece of wire. In this case, magnetic field is into the page and current is flowing upwards, mean it's up. So the force on this one will be to the left. So this is direction of force. You can also find direction of force on this side. If you find direction of force on this side, that has to be to the right, because magnetic field is into the page and current is flowing down. This magnetic force is to the right and this magnetic force is to the left. We can also find out direction of force on this side. Now imagine that we have this wire and magnetic field is into the page. So magnetic field is into the page. So magnetic field is into the page and current is flowing to the left. So the force on this wire will be downwards. So this is down. So the force on this one is down. You can also find direction of force on this side of the coil. You will see the force will be up. So in this case, you can see the forces are acting inwards. Why forces are acting on this coil? Because this coil has current and the coil is inside external magnetic field. So there are forces acting on this coil and forces are inwards. So you can say current will be induced in the coil, and then you can say this part you can remove with forces. You can say forces inwards because the coil is inside external magnetic field. So forces on this coil will act inwards. So you can mention this point. Forces inwards, this will be one point. And the second point you will get if you mention there will be forces on this coil because this coil has current and the coil is inside external magnetic field. So this will be one point. And the second point you can say current carrying coil inside external magnetic field. So we can say current carrying coil inside magnetic field. So we can say inside magnetic field, you will get the second mark. And the third mark you will get if you have written there will be forces acting on this one and these forces are directed inwards. Mean it will try to minimize its area. So it will try to reduce the change in magnetic flux. So this is how we can answer this question. I hope this question is clear to you. If you have any question, please leave your questions in comments and I will be answering as soon as possible. And the next video will be on quantum physics from this paper, and that video will be coming very soon. See you in next video. Bye for now. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on photoelectric effect from May June 2022 paper 4 variant 1. In this question, we will discuss some very important points about quantum physics and photoelectric effect. And those concepts are most frequently asked in past papers. And also those concepts are the core concepts in this chapter. Let's study together. Let's improve together. For question number 7, part A, we need to state what is meant by a photon. And this question is most frequently asked question in past papers. So you need to understand how to state what is meant by a photon. A photon is simply a packet of energy of electromagnetic radiation. Or simply you can say quantum of energy of electromagnetic radiations. So let me show you the answer, how you can write down your answer. This is how you can write down your answer. If you have have mentioned quantum of energy, you will get 1 mark, and that is M mark. Means you have to say quantum of energy, or you need to say packet of energy of electromagnetic radiation. If you have mentioned about electromagnetic radiation, you will get 2nd mark, and that is answer mark, means A mark. So you have to get M mark to get answer mark. This is simply how you can state what is meant by a photon. For part B, it is given to us electromagnetic radiation of a varying frequency F and constant intensity I is used to illuminate a metal surface. At certain frequencies, electrons are emitted from the surface of the metal. The variation with F of the maximum kinetic energy of the emitted electrons is shown in figure 7.1. For part B1, we need to state the name of this phenomenon, and this is photoelectric effect. So simply we can say this one is photoelectric effect. If you write down photoelectric effect, you will get 1 mark, and this is B mark. Very straightforward question, and this is typical graph between kinetic energy maximum and frequency, and this is due to photoelectric effect. For the second part, we need to describe 3 conclusions that can be drawn from the graph in figure 7.1. The conclusions may be qualitative or quantitative. Now, if you look at this figure, the first thing you will notice is that the gradient of this line is constant. So we can say gradient of line is constant. So gradient of line is constant, and gradient is equal to Planck's constant. If you want to write down, you can also say gradient of line is Planck's constant. And the second thing you can find out from here is that if you look at this point, below this frequency, there is no emission of electrons. But after that, there is emission of electrons. Before that, electrons are not emitted. After this frequency, electrons are emitted. So we can say there is a minimum frequency required for emission of electrons. So we can say minimum frequency required. And the third point we can write down, if you look at kinetic energy maximum of electrons and frequency, you will see as frequency is increasing, kinetic energy maximum is also increasing. So we can say in this case, Emax increases linearly with frequency. So you can write down these 3 points. So this is what we can conclude from this figure. Now let me show you how you can write down your answer. So this is how you can write down your answer. In your answer, you can mention the first point. There is frequency below which no electrons are emitted, means there is a minimum frequency required. Then second, you can say Emax increases linearly with increasing frequency, and gradient of the line is constant, and that is equal to Planck's constant. And this question has 3 marks, so you will get 1 B mark here, and the second B mark, and you will get third B mark. For part C, it is given to us the experiment in B is repeated twice, each time making 1 change. State with a reason how the graph obtained would compare with figure 7.1 when a different metal is used but keeping the intensity of the radiation same. Now first of all, let's try to write down the equation for this graph. So simply we can write down in this case HF, mean this is the energy of the photon. This will be equal to work function plus kinetic energy maximum. So we can say KE max. We can rearrange this one. We can simply say K max. This one will be equal to HF minus work function. Now if we compare this one with straight line equation, simply we can write down y is equal to mx plus c. In this case, gradient of the graph is equal to Planck's constant, and y-intercept, this one is equal to work function. Now if we change the metal, means the metal is changed, so we are using different metal, and different metals, they have different threshold frequency, or they have different work function. So this is the first thing we need to understand. Different metals, they have different work function. As value of work function will change, it means the y-intercept will change. Different metals, they have different work function, and work function is equal to HF naught. So if the work function is different, it means that threshold frequency also will be different. If work function is lower, it means threshold frequency will be lower. And if work function is greater, it means threshold frequency will be greater. And if work function is different, y-intercept will be different. So simply we can understand this one with the help of this graph. So we can extend this axis. So this is the threshold frequency for given metal. Now if we extend this line, we can also find out value of work function. So this is value of work function. Now let me show you this one for a metal that has lower work function. So we can draw the line here. So this metal has lower work function. You can see these two lines, they have the same gradient because gradient is equal to Planck's constant, but their y-intercept is different because they have different value of work function, and the threshold frequency is also different. We can also draw another line for a metal that has higher work function. So it also has higher threshold frequency. So this is the threshold frequency. This one is the threshold frequency. So these 2 points we need to understand. So let me show you how you can write down your answer. This is how you can write down your answer. In your answer, you can mention gradient of the line unchanged because gradient is equal to Planck's constant, but y-intercept is different because work function for different metals is different. Then this is the explanation. Different intercept. Why? Because different metals, they have different work function, or you can say different threshold frequency. So these 2 points you have to mention in your answer. So this one is 1 mark for the explanation, and this one is for the statement, and this is also B mark. For the second part, it is given to us when the same metal is used but with electromagnetic radiation of intensity 2i. In this case, intensity simply means that number of photons have been increased. So we can write down here, intensity here simply means that number of photons have been doubled. So we can say number of photons have been increased. So intensity here simply means that number of photons have been increased. So the number of photons reaching the metal, they have been double, now 2 times greater than before. So intensity increase, it simply means that number of photons have been increased. As number of photons increase, but it is given to you that same electromagnetic radiation. They also have to mention here same electromagnetic radiation but with double intensity, but they haven't mentioned this one same. It simply means that electromagnetic radiation is the same. So we can say in this case frequency of radiation does not change. So the energy of single photon will not change because F is the same. So energy of single photon is also the same. So if energy of each photon is the same and metal is the same, we can simply write down in this case E max means the kinetic energy maximum. This is equal to HF minus work function. Metal is same. So same metal means same work function. We can write on here same metal. It means same work function. So there is no change in work function. As electromagnetic radiation is the same, it means frequency is also the same. So we can say same EM radiation with the same frequency. So we can say same EM radiation. So it means same frequency. If frequency is the same, work function is the same, it means there is no change. So kinetic energy maximum also will be the same. So it simply means that there is no change in this line. If we increase the intensity, simply means we increase number of photons reaching the surface per unit time. There will be no change in this graph. So these 2 points we have to mention. So we can write down line unchanged because photons, they have the same energy. Now let me show you how you can write down your answer. In your final answer, you have to mention these 2 points, and this is how you can write down your answer. If you have mentioned these 2 points in your answer, you will get 2 marks. The first mark is B mark if you have written photons have same energy, and second mark is also B mark if you have written line unchanged. You will get second B mark. This line is unchanged because gradient is equal to Planck's constant, and Planck's constant is constant. And y-intercept does not change because same metal, same radiation, same metal, so work function is the same. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on nuclear physics from May-June 2022, Paper 4, Variant 1. In this question, we will discuss some very important points about this topic. We will talk about binding energy. We will discuss how we can state binding energy in a proper way so you can get full marks. Then we will talk about binding energy per nucleon and mass number. How we can sketch a graph between binding energy per nucleon and mass number. Then we will talk about nuclear fusion. We will discuss when energy will be released from nuclear fusion and when energy will be absorbed by nuclear fusion. Very important point we will discuss in this video. Then we will talk about energy released in any nuclear reaction. How we can calculate energy released. So in this video, we will discuss some very important points about nuclear physics. Let's study together. Let's improve together. For our question number 8, part A1, we need to state what is meant by nuclear binding energy. And this question is very common in past papers, so you need to understand how to state nuclear binding energy in a proper way so you can get full marks. We will try to understand nuclear binding energy using example of helium nucleus. Let's try to sketch first of all helium nucleus. Helium nucleus has 2 protons and 2 neutrons. So this one is helium nucleus. It has 2 protons and it has 2 neutrons. Now we need to understand what is binding energy. Binding energy simply means that in order to separate these nucleons from each other, far away from each other, so they don't experience strong nuclear force. Theoretically, we will say we will take these neutrons to infinity, means very far away from each other. So we will take this one to infinity, but this is just theoretical. And we take this neutron to infinity as well. Take to infinity. And we take this proton to infinity as well. So we can say at infinity. And we take this proton to infinity as well. So now these nucleons, they will not experience any force. So in this case, the amount of work done to take these nucleons from the nucleus to infinity, the total amount of work done, that is binding energy. Simply means that much energy we have given to these nucleons to separate them. In this case, the amount of work done to separate these nucleons is equal to binding energy of this nucleus. So simply we can say in this case the work done by external agent, this is equal to binding energy. So simply we can write down here work done is equal to binding energy, is equal to binding energy. We can also redraw this diagram. So here we have the nucleus. We can write down this one is the nucleus. And now we have separated nucleons. So we can draw one proton here. We have one neutron here. And we have one neutron here. And we have one proton here. So they are separated nucleons. So simply we can say these nucleons, they are separated nucleons. Separated nucleons. Now we need to compare the mass of individual neutron with the mass of neutron in the nucleus. In this case, the mass of individual neutron has to be greater than the mass of neutron in the nucleus, because in this case the amount of work done is the energy given to these nucleons. So as these nucleons, they gain energy, so the mass has to increase. Means the amount of work done has been converted into mass, means energy has been converted into matter. So the mass of this nucleon is greater than mass of the nucleon in the nucleus. So simply we can say the mass of this neutron, separated neutron, or the mass of separated proton is greater than mass of the proton in the nucleus. So separated nucleons in this case, they have greater mass because they have gained energy in form of mass, means the mass has been increased. So individual proton is heavier than proton in the nucleus. So these are lighter. We can simply say they have smaller mass. Now if we compare total mass of this nucleus with mass of these separated nucleons. Total mass of separated nucleons will be greater than mass of nucleus, because in this case the amount of energy which is supplied that has been converted into matter, means the mass of nucleons has been increased. So in a simple way you can understand what is binding energy. So this is very simple explanation to teach you what is binding energy. I hope this concept is clear to you, because most of the time students, they are very confused about this one. Let's try to understand this one a little bit in a different way. Now you need to understand, if you go from nucleus to individual particles, or simply you can say individual nucleons. So in this case you have to do work, so energy will be absorbed. So we can simply say energy absorbed. In this case energy will be absorbed. But if we take these and we make them one nucleus, like we have in fusion, in this case energy will be released. So simply we can say in this case energy will be released. Now we need to understand, in this case binding energy per nucleon increases. From here you can understand, if binding energy per nucleon increase, it means energy will be released, and if binding energy per nucleon decrease, it means energy has to be absorbed. So simply we can say when energy is released, mean E released, or simply you can say energy will be released from a nuclear reaction when binding energy per nucleon increases. So energy is released when binding energy per nucleon increases. Very important point. Binding energy per nucleon increases. As you can see in this case, if you have individual nucleons, mean individual neutrons and protons, and we fuse them together and we make them one nucleus, in this case binding energy per nucleon will increase and energy will be released. And vice versa is also true. If binding energy per nucleon decrease, in that case energy will be absorbed. So energy absorbed. So we can say if binding energy per nucleon decreases, so binding energy is equal to amount of work done to separate the nucleons. Now let's try to write down our answer for this question. In order to write down the answer, you have to mention these points. You have to mention the binding energy of a nucleus is equal to the energy needed to separate the nucleus into individual nucleons completely to infinity. So let me clean first of all so you can see what I have written. Completely to infinity. If you write down these points, you will get 2 marks. So this is how you need to state binding energy in a proper way. For the second part on figure 8.1, we need to sketch a line to show the variation with nucleon number A and binding energy per nucleon of a nucleus. It simply means that we need to sketch a graph between binding energy per nucleon of a nucleus and mass number. Don't get confused with line. It simply means that you need to sketch a graph. It can be a line, it can be a curve. So let's try to sketch the graph between binding energy per nucleon and mass number. This is a typical type of curve. You need to understand this curve from nuclear physics chapter. You need to understand how to sketch. So simply we have to sketch this curve. You will see it will reach one peak, and after that the gradient of this one will decrease. So this is how you need to sketch this one. So this is how you need to sketch. So the peak has to be closer to 0. So this is the peak. It has to be closer to the left side. And after this one, after the peak, gradient has to be shallow. This gradient has to be shallow, and before the peak, gradient has to be steep. If you draw a curve like this, you will get 2 marks. It should not start from the origin, but it has to start very close to the origin, not from origin. If you sketch your curve like this, you will get 2 marks. And this one is the simplest form of binding energy per nucleon against mass number curve. But actual binding energy per nucleon against mass number curve is different. So let me show you the actual one. But for this question, you no need to draw this one. If you draw simply this curve, you will get 2 marks. But you need to understand this one is the actual binding energy per nucleon against mass number curve. This is, you can see some spikes here. But for this question, you no need to draw these spikes. You can simply draw one continuous curve and you will get 2 marks. For part D, it is given to us in one type of nuclear process, deuterium undergoes nuclear reaction. For part 1, we need to state the name of this type of nuclear process. In this case, you can see we have 2 deuterium nuclei. These 2 deuterium nuclei, they combine together, or simply we can say they fuse together to form the helium nucleus. Helium nucleus has higher mass number. It means this nucleus is heavier than deuterium. So in this case, these 2 lighter nuclei, they fuse together to form a heavier nucleus. So this process is nuclear fusion. So simply you can say this one is nuclear fusion. If you simply write down fusion, you will get 1 mark. And this is B mark, mean it has to be in your answer. For the second part, we need to explain with reference to over line means over graph in A2 why this reaction results in the release of energy. We have already discussed energy is released if binding energy per nucleon increases. Binding energy per nucleon increases. Let's try to understand this one with the help of this curve. In this case, we have 2 deuterium nuclei. They combine together and they form one heavier helium nucleus. So you can see in this case, binding energy per nucleon is increasing. So we can say binding energy per nucleon in this reaction increases. Binding energy per nucleon increases. So this is one point you have to mention in your answer. And the second point you can write down. In this case, the mass number of helium is greater than the mass number of deuterium. So second point, we can also say mass number increases. Means the mass number of products is greater than mass number of reactant. So energy will be released. As binding energy per nucleon increases, it simply means that energy is released. So energy released. So these 2 points you have to mention in your answer. Now let me show you how you can write down a proper answer. This is how you can write down your final answer. You can say both particles have low A values, or simply you can say helium nucleus has higher mass number. Then you can write down helium has higher binding energy per nucleon than deuterium. So in this case, energy has to be released. For part C, in table 8.1, masses of the particles are given and we need to calculate energy released when 1 mole of deuterium undergoes nuclear reaction. First of all, let's try to understand when energy will be released. Energy only will be released if the mass of the reactants is greater than mass of products. Let's say mass of reactants is equal to M1 and mass of products is equal to M2. So in this case, M1 has to be greater than M2. So the mass difference that will be converted into energy and energy will be released in this nuclear reaction. So we can calculate mass difference. So we can say M1 minus M2. This one will be equal to mass difference, or we can also call this is mass defect. Now let's try to calculate first of all mass difference or mass defect. So we have to consider mass of these 2 nuclei. So simply we can say 2 times 2.014102. So this is mass of these 2 nuclei. This is mass of these 2 nuclei, and we need to subtract mass of helium nucleus and neutron. So we can write down mass of helium nucleus 3.016029 plus we have mass of neutron 1.008665. If we subtract this, we will get mass defect, value of mass defect, that is equal to 0.00351 U. So this is in U. We have to be very clear. This given unit is AMU. Now we need to calculate energy released. Energy released by one reaction. That one will be equal to mass difference times C squared. But mass difference we have in AMU. We need to understand 1 U is equal to 1.66 times 10 to negative 27 kgs. 1 U is equal to this, but we have this much U. So simply we can say in this case 0.00351, we have to multiply this one with 1.66 times 10 to negative 27. So this is now in kgs, and we need to multiply with constant C, that is equal to 3.0 times 10 to 8 square of this value. If we solve this one, we can calculate energy released in one nuclear reaction. Energy released in this case will be equal to 5.24 times 10 to negative 13 joules. So energy released in one nuclear reaction is equal to this one. But we need to calculate energy released when 1 mole of deuterium undergoes nuclear reaction. 1 mole. Now you need to understand, if we have 1 mole here, so how about the number of nuclei of helium? That will be half. So we can simply say if we have 1 mole of deuterium, we will get 0.5 mole of helium. 0.5 mole of helium. Very important point. Now we can simply write down here total energy released. So this one is the total energy released. We need to calculate total energy released. Total energy released will be equal to energy released in one nuclear reaction, means simply we can say E, energy released in one nuclear reaction. So simply you can say energy released in one nuclear reaction, times number of reactions. So we have to multiply with number of reactions. In this case, we have energy released in one nuclear reaction, that is equal to 5.24 times 10 to negative 13. So this is energy released in one nuclear reactions. We need to calculate number of nuclear reactions. In this case, we have already discussed, if we have 1 mole of deuterium, it will form 0.5 mole of helium. 0.5 mole of helium. Now we need to understand 1 mole of any substance. It has number of atoms, or you can say number of molecules, or in this case simply you can say number of nuclei. That one will be equal to 1 Avogadro's number. So we have to write down this one will be equal to 6.02 times 10 to 23 atoms or molecules, or you can say nuclei. But in this case we have half, so we will write down 6.03 times 10 to 23 divided by 2. And if we multiply this one, we will get total energy released. And total energy released in this case will be equal to 1.58 times 10 to 11 joules. A lot of energy. So if you compare this energy with this one, you can see in one reaction, very little energy is released. But in 1 mole, a lot of energy is released. And this is our final answer. If you have written all these steps, you will get 5 marks for this question, because the total marks for this question are 5. So this is how you can answer. This is a standard method to calculate energy released in any nuclear reaction. In this question, only difficult part is this one. 1 mole. If we have 1 mole of deuterium, how many moles of helium nucleus will we get? That will be 0.5, because 2 deuterium nuclei, they combine to form 1 helium nucleus. And that is a little bit tricky part. So that's the reason we have divided this one by 2. And this is our final answer. I hope this question is clear to you. If you have any questions, please leave your questions in comments. See you in next video, and next video will be coming very soon. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very nice question on medical imaging from May June 2022, paper 4, variant 1. In this question, we will talk about X-rays. We will discuss how X-rays can be produced and how we can calculate transmitted intensity when X-rays pass through 1 medium. We will also talk about transmitted intensity when X-rays pass through two different media. We will also discuss the main difference between X-rays and CT scan. At the end of this lesson, we will also talk about good contrast and poor contrast. And these are key concepts about X-rays. So listen carefully and try to improve your conceptual understanding of X-rays. Let's study together. Let's improve together. For question number 9, part A1, we need to explain how X-rays are produced. And this question is quite common in past papers. So let's try to understand this one step by step. First of all, if you look at this image, you can see we have cathode here. As this cathode is heated using low voltage, electrons are released. So simply we can say in stage 1, cathode is heated. So simply you can say cathode is heated. As cathode is heated, electrons are released. We can simply write down electrons released. In this case, electrons will be released, and we use low voltage. So you can also write down here, in this case, low voltage is used to release electrons from cathode. As electrons are released, you can see this is beam of electrons. So these are electrons. These dots are representing electrons. And then these electrons, they are accelerated using very high voltage. So we can write here very high voltage. And the range of this voltage can be from 10 kilovolts to 120 kilovolts for medical use. 10 to 120 kilovolts, very high voltage. As these electrons, they will reach target, tungsten target. So this one is tungsten target. They will hit this target and they will decelerate. So second stage, we can say stage 2, electrons are accelerated. So simply you can say electrons are accelerated using high voltage. So simply we can say electrons are accelerated using high voltage. So this is the second stage. And in third stage, you will see electrons hit the target and decelerate. We can say electrons hit the target, tungsten target, and decelerate. Hit the target and decelerate. So very important point. Electrons decelerate. In stage 4, we can say as electrons they decelerate, their kinetic energy decreases. Stage 4, kinetic energy of electrons decreases. So the kinetic energy of electrons will decrease, and this decreasing kinetic energy will be converted into X-rays. It simply means that kinetic energy of electrons will be converted into X-rays. This is how X-rays are produced. These are X-rays. So these X-rays are produced simply by decelerating accelerated electrons. So this is the process you need to understand about production of X-rays. Now let me show you the answer, how you can write down your answer in a proper way. This is how you can write down your answer if you have mentioned electrons are accelerated by an applied potential difference. You will get 1 mark. As electrons hit the target, they will decelerate. You will get another mark. X-rays are produced. So this is how you will get 3 different marks. 1 mark here, you will get this one is B mark. And the second mark you will get if you have written electrons hit the target, you will get second B mark. And third B mark you will get if you have written X-rays are produced when electrons decelerate. Mean if you write down this, you will get third mark. This is how marks will be awarded. For the second part, we need to state why X-ray images are taken of multiple sections of the body during CT scan. For this question, we need to understand the difference between CT scan and X-ray. In X-ray, we can get 2D image, but with the help of CT scan, we can get 3D image of any part of the body. In order to get 3D image, we need to take multiple images of multiple sections of that part of the body, and then we combine them to create 3D image. And that's the main difference. With the help of CT scan, we can get three-dimensional image. We can rotate and we can view from different angles. So that's the reason when we go for X-ray, they will just do X-ray one time from one direction. But if you go for CT scan, they will repeat the process again and again to take multiple images of multiple sections of the body. So that's the main difference between CT scan and X-rays. So let me show you how you can write down your answer. Discussion has only 1 mark. If you have written images of the multiple sections are combined to create a 3D image, you will get 1 mark, and this is the mark. For part B, it is given to us an X-ray image is taken of the structure shown in figure 9.1. Linear attenuation coefficient of bone is given, and this one is equal to 3.4 per centimeter. And linear attenuation coefficient of soft tissue is given, and that is equal to 0.89 per centimeter. The incident X-rays are parallel and have a uniform intensity I0 across the structure. Determine in terms of I0 intensity of the detected X-rays from point P. So first of all, we need to find out intensity of X-rays detected at this point. We need to understand when X-rays will pass through the soft tissues, the intensity will decay exponentially. So we can simply draw here the intensity will decay exponentially, somewhat like this. So initial intensity is I0, and intensity detected at this point, we can say this is I1. So we need to understand how I1 is linked with I0. So this is just exponential decay. We can say I is equal to I0 e to the power of negative mu x. In this case, I1, this is the transmitted intensity. So this one is transmitted intensity. So you need to understand these quantities. Transmitted intensity. I0, this one is incident intensity. So this is incident intensity. Mu is attenuation coefficient. So this is linear attenuation coefficient. And X is the thickness of tissues. So we can say this one is thickness. Now simply we need to plug in values and we can find out value of I1. So we can write down I1 means the transmitted intensity detected at this point. This one is equal to I1 and this one is equal to I0 e to the power of negative mu. We are talking about the soft tissue. So it is passing through the soft tissue. So this is given to us. This is soft tissue. So we have to use 0.89. So this is 0.89. We have to multiply this one with thickness, and thickness is 5.6 centimeters, and this is per centimeter, so it means centimeter per centimeter, they will be cancelled, so we no need to write down centimeter here. We simply need to solve this. So in this case we can simply say I1, this one will be equal to, if we solve this one, we will get 0.0068 I0. So this is value of I1. For the second part, we need to calculate intensity at point Q, means intensity of detected X-rays at this point. But in this case, X-rays will pass through soft tissue and they will also pass through bone. So we have two different medium in this case. Let's try to understand this one in detail. Imagine that we have soft tissues. So this is soft tissue and we have bone. So the second medium is bone. So this is bone. We can also label this one. We have soft tissue first of all. X-rays will pass through soft tissue, then they will pass through bone. Thickness of soft tissues, we can simply find out that one will be equal to 5.6 minus 2.4, and this one will be equal to 3.2 centimeters. And the thickness of bone is given to us. X bone we can write down. X bone is given, that is equal to 2.4 centimeters. Simply you can read from here. We can say thickness of soft tissue is x1 and the thickness of bone, let's say this is x2. So the mu for soft tissues we can say is mu1 and the mu for bone, let's say, is mu2. Value of mu for soft tissues is given to us, that is equal to 0.9 per centimeter. And value of mu for bone is also given, that one is equal to 3.4 per centimeter. Now we have value of x, we have value of mu, so we can calculate intensities. In this case, it is also given to us the incident intensity is I0. Means this here we have incident intensity. When X-rays will pass through the soft tissues, as value of mu is small, so they will decay slowly. So they will decay like this, decay slowly. But bone has high value of mu, so they will decay quickly, somewhat like this. So they will decay quickly. Imagine that at this point we have intensity I1 and finally we have intensity at point Q, that is equal to I2. So we need to calculate I2. First of all, we can calculate I1. I1 will be equal to I naught e to the power of mu1 negative mu1 x1, because this is for soft tissue. Now we can calculate I2. So I2 will be equal to intensity at this point. So we have intensity I1 times e to the power of mu2 x2. This is for the bone. So I2 finally we can write down. I2 will be equal to I naught. In I1 we can replace with this. So I1 is equal to I naught e to the power of negative mu1 x1. So we can write down e to the power of negative mu1 x1, and here we have e to the power of negative mu2 x2. Now simply we need to plug in values of mu1, mu2 and x1 and x2, and we can find out value of I2. So I will be writing here, so I2 in this case is equal to I naught e to the power of mu1, that is equal to 0.89. We have to multiply this one with negative sign. Multiply by x1. x1 is 3.2. Now we have to multiply e to the power of negative mu2, and mu2 is 3.4 times thickness is 2.4. Now simply we need to solve this one. You can use calculator, e to the power of minus, and you can find out the value of I2. In this case, value of I2 will be equal to 1.7 times 10 to negative 5 times I naught. Simply in your calculator you have function e, and here you have the exponent, and then you can find out value of this. Simply use this function and you have the power, and you can find out the answer. If you will do this calculation, this one will be the final answer. So simply we can write down final answer is 1.7 times 10 to negative 5, and this is the final answer. This question has 2 marks. You will get the first mark if you have written this step. You will get 1 C mark. And the second mark is the answer mark. If you have got the right answer, you will get 2 marks. This is for 2 media. But if you need to write down this one for 3 medium, let's say we have another medium here. So I3 simply will be equal to I naught times e to the power of negative mu1 x1, e to the power of negative mu2 x2, e to the power of negative mu3 x3. So you can also find out value of I3. Let's say I3 at this point, so you can also find out I3 here. For any number of media, it doesn't matter. Same approach you can use. For part C, we need to explain with reference to our answers in B whether the X-ray image of the structure in figure 9.1 has good contrast. In order to decide contrast is good or poor, we have to look at intensities. At point P, we have calculated intensity that was equal to 0.0068 times I naught. We have also calculated intensity at point Q. Intensity at point Q was equal to 1.7 times 10 to negative 5 times I naught. Now we can find out the ratio between IP and IQ. If we calculate this ratio, we can say IP divided by IQ. We can find out this ratio. IP is equal to 0.0068 times I naught divided by 1.7 times 10 to negative 5 times I naught. If we simplify this one, I naught we can cancel with I naught, we will get around 400. It simply means that IP is 400 times greater than IQ. So there is good contrast. So simply we can say in this case IP is greater than IQ about 400 times, So simply you can say good contrast. You can also write down like this. You can say ratio between IP and IQ is equal to 400. So good contrast. So simply you can write down. So good contrast. Good contrast. It simply means that if you will look at point Q, less number of X-rays they can reach at this point. So this area will stay white. So this part of the screen will be white and this one will be dark because X-rays can reach here. More X-rays can reach this part. So you will see white and dark. And there is a big difference between this part and this part. So we will have good contrast. It simply means that the white part and you have the dark part. So this will give you the good contrast. So if you look at this one, this has very good contrast. Dark part is too dark and the white part is brighter. So this has good contrast. But if you look at this one, this doesn't have very good contrast because this is also dark, this is also dark. So it is not very good contrast. So this is how you can approach. This question has only 1 mark. If you have written these 2 points, you will get 1 mark. And that one is B mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on astrophysics from May June 2022, paper 4, variant 1. I said this question is very important because the points we will cover, those points are the key concepts from this topic. In today's class, we will talk about Wien's displacement law and also we will do some calculations based on Wien's displacement law. We will also talk about redshift and some other important points about astrophysics and cosmology in today's class. Let's study together. Let's improve together. For question number 10, part A, we need to state Wien's displacement law. Wien's displacement law simply tells us relationship between lambda peak means wavelength of maximum intensity and thermodynamic temperature, or simply you can say temperature in Kelvin. And these two quantities, they are inversely proportional. Lambda peak means that value of the wavelength of this peak. So simply you can read this one from x-axis. And temperature in Kelvin. We can also write down this one in equation form, that lambda peak is equal to some constant divided by T. And K in this case is equal to 0.00289. So we can write down in this case lambda peak times temperature in Kelvin. This is equal to 0.00289, and this is Wien's displacement law. So you have to be very clear about lambda peak. This is value of the wavelength at this peak. For example, in this case, this value, this is lambda peak. Wavelength of maximum intensity means you have to find the value of the wavelength where intensity is maximum, and that one is called lambda peak. Now let me explain to you how you can write down the answer. When you answer, simply you can say wavelength of maximum intensity is inversely proportional to thermodynamic temperature. If you write down this one, you will get 1 mark, and this is the mark. For part B, it is given to us figure 10.1 shows the wavelength distributions of electromagnetic radiation emitted by two stars A A and B. The surface temperature of star A is given, that is equal to 5800 kelvins. We need to find out the surface temperature of star B. So in this case, we need to understand how to use Wien's displacement law. We can find out for star A, we can write on here. For star A, we can find out lambda peak. For star A, the value of the lambda peak simply you can read from here. So the lambda peak for star A is equal to 0.5. So this is 0.5 micrometer. And temperature for star A is given, that is equal to 5800. So this is 5800. For star B, we can also get value of lambda peak. We have to simply read from here. So in this case, this is the peak, so we can draw this line down. So we have to read x-axis. In this case, this is 0.5, so this will be 0.6 and this will be 0.7 and this is halfway. So this value will be equal to, so simply we can write down this is 0.65 micrometers. Now we need to find out value of TB, means temperature of star B. We need to find out this value. We can say this is temperature A, means temperature of star A. So simply we need to use Wien's displacement law. According to Wien's displacement law, lambda peak times temperature in kelvins, this is equal to constant, and simply you can say this is equal to 0.289, and this is true for any star. So you can see from here, if lambda max increase, temperature of the star will decrease. So in this case, this lambda max is greater, so means temperature of star B has to be lower than temperature of star A. So our answer has to be lower than this value. Now we have to use simply ratio method and we can find the answer. So in this case, we can say lambda A times temperature A. This one has to be equal to lambda B times temperature B. We need to find out value of temperature B, means temperature of star B. So we can write down lambda A times temperature of star A divided by lambda of star B. Now in order to calculate surface temperature of star B, simply we need to plug in these values. Lambda A is given to us, that is equal to 0.5 micrometers. In this case, you no need to convert units, but if you want to convert units into meters, that is very good practice. You can convert. So in this case, we will multiply with 10 to negative 6. Multiply with surface temperature of star A. Surface temperature of star A is given, that is equal to 5800, and this has to be divided by peak wavelength of star B, that is equal to 0.65 micrometers. So we have to multiply with 10 to negative 6. In this case, you don't need to convert this wavelength into micrometers because these units will be cancelled. So we can cancel this one with this. Now if we simplify this, our final answer has to be equal to 4500 Kelvin, and this is surface temperature of star B. So our final answer for this question is 4500. This is surface temperature, 4500. For the second part, it is given to us star B appears less bright than star A when viewed from the Earth. Let's try to understand why star B is less bright. In order to find out why star B is less bright, we need to look at temperatures of star B and star A. Temperature of star B is lower than temperature of star A. That's the reason star B appears less bright. So simply we can write down here less bright, because this temperature is equal to 4500 kelvins and this temperature is equal to 5800 Kelvin. Now question is asking us, we need to use figure 10.1 to suggest with a reason how else the physical appearance of star B compares with that of star A. So we have to compare another physical appearance of star A and star B. If you look at the wavelength of star B, we have already discussed and we have found from this figure, wavelength of star B was equal to 0.65 0.5 micrometer. So simply you can write down micrometer. And the wavelength of star A was equal to 0.5 micrometers. Now in this case, the peak wavelength of star B is greater than peak wavelength of star A. So the star B in this case will appear redder. So the star B will appear redder. In this case, star B appears redder because its wavelength is closer to the red side of visible spectrum. So that's the reason this one appears redder. For the answer of this question, simply you need to write down star B appears redder because the peak wavelength of star B is greater than peak wavelength of star A. So let me show you the answer. For the answer of this question, simply you can write down first of all star B looks redder, then you need to explain, suggest with a reason. So you will say because it has greater peak wavelength, means greater than peak wavelength of star A. If you write on this, you will get 2 marks. 1 mark you will get if you have written star B looks redder, you will get 1 mark, that is B mark, and the second mark you will get if you have explained, you will get the second mark why it appears redder. For part C, it is given to us the lines in figure 10.1 have been corrected for redshift. For part C1, we need to state what is meant by redshift. You have to be very clear about redshift because understanding of this term is very important for this topic. Let's try to understand what is redshift. Redshift simply means that the apparent wavelength of light, apparent wavelength are simply, you can say, observed wavelength. This one is greater than lambda actual, means actual wavelength of light emitted by star, and this is called redshift. Redshift means that the wavelength, apparent wavelength, is greater than actual, and this is shifted towards red end of the spectrum, of visible spectrum. That what we call is redshift. And when it is possible, it is only possible if the source is moving away, means source of light is moving away. In this case, simply you can say if the star is moving away, the wavelength will be shifted towards red end of visible spectrum. That's all what we need to understand about redshift. And vice versa is also true. If the star is approaching, but in the universe, most of the stars, almost every star is moving away from us, means moving away from each other. So we observe most of the time redshift. But blue shift is also another term. Blue shift means that lambda apparent is lower than actual lambda. So we can say lambda observed is lower than lambda actual. And that is only possible if the star is approaching. But in our universe, everything, stars, galaxies, all of them, they're moving away from each other. So we observe most of the time, means all the time, we observe redshift. Only we observe blue shift for one galaxy, Andromeda. That is approaching. So that is something unique. But for rest of the stars and galaxies, what we observe is we observe redshift. Now let me show you how you can write down the answer for this question. For the answer of this question, simply you can write down apparent wavelength is greater than actual wavelength of light emitted by star because star is moving away from observer. This question has 2 marks. If you have written the first point, you will get 1 B mark, and the second B mark for writing the second point. So this is how marks will be given to you. For the second part, we need to explain how cosmologists are able to determine that light from a distant star has undergone redshift. Very nice question. So first of all, let's try to understand about this, what's going on. We need to understand, as a cosmologist or as a scientist, how do we know about distant stars and distant galaxies? We have never been to any star or any galaxy other than our own planet and moon. So as human beings, we have been to moon only other than our planet. But we study about universe. We study about different galaxies, we study about different stars, and we study about this whole universe. So how do we study? Only we study the light coming from galaxies and from stars. That is the only thing we have to study distant stars and galaxies. So how do we study? We will observe, we will examine the spectrum of the light from the star, and then we compare spectrum of star with the spectrum of light in lab. So by examining and by comparing, we can study stars. That's all what we do, and that's what you need to understand for this question. Let's try to understand this one with one simple example. In this figure, you can see we have two different spectrums. We have one spectrum for sun and we have another one for galaxy. So we have these two different spectra. Now if we compare these two, you can see this line you see in the spectrum of the sun and the same line you see in the spectrum of galaxy. But this line is shifted towards red end of the spectrum. And if you compare these two lines, you can also see this is shifted towards red end of spectrum, and these two lines, these are also shifted towards red end of spectrum, and so on. This simply tells us that the light from distant galaxy is shifted towards red end of visible spectrum. It simply means that galaxy is moving away from us. So this is how we can find out if any star or galaxy is approaching us, or star or galaxy is moving away from us, by simply examining and comparing their spectra. So this is how we study our universe. Now let me show you the answer, how you can write down the answer. Simply in this case, you can say by examining the lines in the spectrum of light from the star. So you will get 1 mark, and that is the mark. You will get 1 mark. Then second mark you will get if you have written by comparing with non-spectrum, means spectrum in the lab. You will get the second point. This question has 2 marks. This is how these marks will be awarded. And this is end of this paper, paper 4.1. We have finished this paper, and paper 4.2 will be coming very soon. So if you have any questions from any paper, or you have any doubts, you can leave your questions or your doubts in comments, and I will be answering as soon as possible. See you in next video. Bye for now.